Hi scholars, Ms. Perez here again with our next lesson. Today we are going to be exploring Unit 6, Lesson 3 on how charges interact with each other. For today, you should have your Google Classroom open and your classwork document open. Right. Remember, we try to keep our tabs at the minimum in order to minimize our distractions. So again, today we are going to be explaining how charge interactions occur. So the materials that you'll use today are your notebook, your pen and pencil, and then the tabs that I just explained. So today's guiding question is going to be, what is the relationship between a particle's charge and of the force it exerts on other charged particles? So we're going to be doubling in a little bit on the force that's creating these interactions between particles. Yesterday in the PhET simulation that you did, you saw how by rubbing the balloon against the sweater, the charges exchange from one object to the next. And that caused the balloon to be attracted to the sweater, and it also caused the balloon to be attracted to the wall. So we're going to learn a little bit more about what is actually bringing these two objects together. So our agenda for today, we'll be doing a do now. I'm going to do a reading. We'll stop for a quick check for understanding. Then we'll continue on with our reading. We'll watch this quick video, see some key points, and then we'll do our exit ticket. The aim for today will be to deepen our understanding on how charged particles interact with each other. So let's start with our do now. So let's consider the following clip. In your Google document, respond to this answer, to this question. What is causing the soda can to move? And so I am going to play just a short part of this video. So just as before we start, I'm going to link this video onto your Google, it's linked on your Google classwork, so you can watch the whole thing if you're interested. It's actually pretty cool. All right, so let's pay attention. What is the person doing to the rod and what's happening to the soda can? Right, so we'll stop there. So take the next minute to write in your classwork document, what do you think is causing the soda can to move? What did you observe? And why do you think this is happening? Press pause when you're ready to start, and then press play when you're ready to come back. Press pause now. All right, scholars, welcome back. We're not going to go over what your answers to the do now are right now, because it's going to become a little clearer as we go on through the lesson. So just keep your thoughts in the forefront of your mind as we're doing the reading and the exploration today. Okay, so today's reading has two parts. You're going to take the next 8 minutes to read and annotate the first part, and then you're going to stop when you see the check for understanding. When you are ready, press pause so that you can start your reading. Press pause now. Right, scholars, welcome back. So let's do a quick check for understanding. So electrical forces are, electrical forces can cause objects to only attract each other. They can cause objects only to repel each other. They can cause objects to attract or repel each other, or they have no effect on other objects. So based on your reading, which answer do you think is correct? Take the next 30 seconds or so to write your response into your Google classwork. Okay, so based on what we've been seeing in the last few days and based on the reading also, you could think, oh, the objects, we've seen objects repelling each other, and we've also seen objects attracting each other. So electrical forces cause objects to both attract and to repel. So the answer in this case would be C. Okay, let us continue. So now we're going to continue on with the remaining of our reading. This part of the reading discusses how charged objects affect neutral objects, meaning objects that have a neutral charge. This section of the reading follows immediately after the check for understanding that we just did. And once you finish this reading, then press play so we can continue on. Press pause now. Great, scholars, welcome back. Before we move on to our key points, I just want to show a quick demonstration that visually explains to us this concept that we were just reading about, how charged objects can have an attracting effect on neutral objects. So what you're going to see here in this video is, it's a plastic comb that has been rubbed with a cloth, and it's going to attract the small pieces of paper. So these pieces of paper here are neutral. The way that we can notice that they're neutral is because amongst themselves, they're not attracting each other. So they have a neutral charge. There's no electrical forces interacting between them. And for us, that is evidence that these objects are neutral. So then now, this person is going to they just rubbed the comb with some cloth and is going to place it close to, first they haven't done anything to the comb yet. Right now that's just to show us that the plastic by itself is neutral. And then you just notice that they're rubbing the comb with the cloth to transfer charges from the cloth into the comb. So this again connects what we learned the other day about how rubbing or friction creates transfers charges. It doesn't create charge, it transfers charge. It's a very important distinction. So now we see how by placing the charged comb onto the pieces of paper that they're actually attracting and they're sticking together. So that's what we would normally call like static electricity, or sometimes we say like the word like that something is like staticky. So we're observing that happening now. Great. So hopefully that video was helpful to kind of wrap up the second part of the reading. Now let's discuss the key points that we should have arrived at through your reading. Please take the next few minutes to write these down into your notebooks while we read them together. So the first key point that you should have arrived is charged particles exert a force onto other charged particles. This force is called electrical force. So this is a definition for us. Any charged object, whether positively charged or negatively charged, will have an attractive interaction with a neutral object. Right, so that was the example we just saw in the video of the comb attracting the neutral pieces of paper. When an object attracts, it is called an attractive force, and then when an object repels, it is called a repulsive force. So these two are a new vocabulary words that we need to have in the forefront of our mind also, and it's important that we have in our notebooks so that we can use these and refer to them later on. All right, so the last thing for today will be to complete this exit ticket. In the bottom of your classwork, you have this image with these two tables next to them. It's asking us to determine what the charge for object A and object C is in each scenario. For both case 1 and case 2, it is telling us the balloon B is negatively charged. Right? So considering the images and the fact that B is negatively charged, what are the charges for A and C? So take the next few minutes to answer this exit ticket. And once you're done, don't forget to submit your classwork to your teacher, and take the remaining time in class to complete any classwork that you might have missing. Make sure that you have read thoroughly through all of the readings and you've annotated using the highlighting feature and made comments on the right side of your document, and to clearly mark your responses into the Google Classroom document. All right, I hope you have a wonderful day.